Hello, we're back with our homework. Our assignment was to do the odd problem, so starting with number 33, name two properties used to evaluate. All right. Well, we have the multiplicative inverse here. And right here, we have the multiplicative identity. Find the value of x, then name the property used. All right. So we're going to subtract 8 from both sides, so x equals 0. This is subtracting a number from itself, so this is the additive identity. 37. We're dividing a number by itself to get x equals 1. Since we're going to multiply both sides by the fraction 1/10, this is the multiplicative identity. We're adding 0 to both sides to get x equals 5. This is the additive identity. Of 0. Well, just additive identity. Next up, multiplying a number to cancel out is the multiplicative identity. No, multiplicative inverse. There we go. Sorry. This is multiplicative inverse. This is inverse. Adding 0, that's additive identity of 0. That's multiplicative inverse. Multi-in. So that's going to give us x equals 1. Then right here, we have an additive inverse to get us 0. So that's going to be add inverse. 45. The triangular banner has a base of 9 centimeters and a height of 6 centimeters. Using the formula for area, 1/2 base times height. Can be expressed as 1/2 times 9 times 6. Gabriel finds it easier to write and evaluate 1/2 times 6 times 9 to find the area. Is Gabriel's expression equivalent to the formula? Yes, this is. Why is it? What we're doing here is we're using our cumulative property of multiplication here. We're multiplying these three numbers. The order we multiply them does not apply. No, it applies, it just the order doesn't matter. So, no matter what, this problem is going to look like this. 9 times 6 over 2. No matter how we pull it apart or group it, right there, we could even write this as 6 over 2 times 9. That's what that grouping also could be represented as. Does not matter. So we'll just say this is the cumulative. Multiply. 47. The human body has 126 bones in the upper and lower extremities, 28 bones in the head, and 52 bones in the torso. Use the associative property to write and evaluate an expression to represent the total number of bones. All right, so we know it's 126 plus 2, 8 plus 5, 2. Well, those last two make this a little bit easy. This is going to combine to make 80. And then 120 and 80 is the 2 and the 8 make it 200. So this is just 206. 49. Write two equations showing the transitive property of equality. Justify your answer. All right. A equals B. B equals C. Thus, A equals C. Determine whether the following statement is sometimes, always, or not that one. Provide examples that show there's no cumulative property or associative property for division. Okay. 2 divided by 4 divided by 5 is going to be it's going to be a bad number, but we can prove that it is not the same as 5 divided by 4 divided by 2. Calculator. 2 divided by 4 divided by 5, 0.1. 5 divided by 4 divided by 2, 0.62. Those two are not equal. What is the relationship in the results when the ordered division of two numbers is switched? Well, we just showed that. 3. 53. The sum of any two whole numbers is always a whole number. As for the set of whole numbers 0 through 4, continuing, it is said that to be closed under addition, this example of the closure property. I didn't learn about that until grad school. State whether each statement is true or false. If false, justify your reasoning. The set of whole numbers is closed under subtraction. The sum of any. So then the set of all whole numbers is said to be closed under addition. So it's saying the subtraction of any two whole numbers will always be a whole number, is what I'm guessing they're saying. So if we have some a minus b, it will always equal some c, such that c is whole. That's true. If you subtract whole numbers, you only get whole parts. Closed under multiplication. This would state that this is always true. A whole number times a whole number will always equal a whole number. And we know from our early days of multiplication that no matter what, when we multiply whole numbers, we always get a whole number. It's only when we use decimals or fractions does that change. The set of whole numbers is closed under division. Now, by what they've given us here, that the closure property is that it's always a whole number. If we take two whole numbers and divide them, it will not equal a whole number, such as 1 over 2 equals 0.5, which is not a whole number. So no, this is not closed under the definition they gave us. We found a single example that did not work, so it does not work for always. This will sometimes work. 55. Identify the equation that does not belong with the other three and justify. All right, so we have addition. This is using a reflexive property. This is just showing you can write it the same way. Let's see, we have a reflexive property and a, let's see, oh, it's not just associative, it's just reordering. So everyone's reordered but this one. Oh no, 7 times h is h times 7. Ooh. Well, all of these ones are reordered. This one is not. The parentheses are just moved. It's grouped differently. The other ones do not have grouping. And that's it. Thank you so much for watching. Hope this helped with your homework.